Okay, today we're continuing our 8.3 notes on inverse trig functions. We ended at the top of page 4, so we're going to continue right where we left off, and we're going to talk about an angle of elevation and an angle of depression. An angle of elevation is an angle measured from the horizontal upward towards a specific object, and an angle of depression is an angle measured from the horizontal but downward towards an object. Okay, so looking at this picture, I'm going to start at this horizontal line every time I'm talking about an angle of elevation or depression. And if I'm talking about an angle of elevation, I go up towards this airplane. If I'm talking about an angle of depression, I go down towards the cat here. Okay, so that's an angle of elevation and an angle of depression. We start at the horizontal and go up or down. Okay, just a quick fact about angle of elevation and depression is that the angle of elevation and depression between the same 2 points are congruent because they are both measured from the horizontal, creating parallel lines and alternate interior angles. Okay, so using some theorems we've used in the past, we can say that these angles will always be the same. They'll always be congruent using alternate interior angles. Okay, and that is the end of what we're going to be learning new stuff today. Now we're just going to be doing some story problems involving what we've been doing the past couple days. Okay, so each one of these on the back side is a story problem. Thing we want to remember on each of these, we're going to read it and we're always going to set up a picture. If you do not draw a picture, you are not going to be able to solve this. There's too much information going on. We can't do this without pictures or without a drawing. Okay, so we're going to draw every single time. The second thing is these story problems, some of them we're going to be using normal trig functions, and some of them we're going to be doing inverse trig functions. Okay, so when we are solving for a side length, we're going to use a normal trig function. And when we are solving for an angle, we are going to use the inverse trig function. That's the key. Side length is normal and angle is inverse. Okay, so let's go over example 1, see what we can find here. So the angle of elevation to the top of the Eiffel Tower from a point on the ground is measured to be 78 degrees. How tall is the Eiffel Tower if the point on the ground is 60 feet from the center of the base of the tower? Okay, so I've got the Eiffel Tower, and I'm not an artist, so it's not going to be very pretty, but I'm going to draw my Eiffel Tower. It's going to look something like this. Doesn't have to be perfect, just as long as you know what it is. It's my Eiffel Tower. That's good enough. Okay. Now, I'm measuring from a point on the ground to the center and the top of the Eiffel Tower. So my triangle is going to look something like this. Okay. Says that the angle of elevation, so starting at my horizontal and going upwards because we're elevation, is 78 degrees. It also says that the ground that we are standing on is 60 feet from the center of the base. So from where we're standing to the center of the Eiffel Tower is 60 feet. And we want to know how tall the Eiffel Tower is. So we want to know this side length right here. So that's our x that we're solving for. Okay, now we're going to do the same steps we've done before. Step 1, identify our angle. Well, our angle is 78 degrees. Step 2, label all your sides. The hypotenuse is the longest and always across from the 90 degrees. The adjacent is touching our angle, and the opposite is what's left. Step 3, we're going to identify which trig function we're going to use. Well, we're using our opposite and our adjacent here. That's going to be a tangent. Opposite over adjacent. Okay? And now step 4, set up our trig equation. We start with tangent because that's the function we identified. The tangent of our angle, 78 degrees, is going to be equal to our ratio, opposite over adjacent. So it's going to be equal to x over 60. Okay, now are we solving for side length or an angle? Well, we're solving for this triangle side length right here. So we're going to use a normal trig function. So to solve this, we are going to cross multiply When we cross multiply, we end up with 60 times tangent of 78 is equal to x. Now I can put 60 times tangent of 78 in my calculator, and I'll find what x is. So when I do that, rounded to one decimal place, I get 282.3 feet. That is how tall the Eiffel Tower is. Okay? Now, looking at the next example, Kate is flying a kite from her hands, which are 2.5 feet above the ground. If she lets all 300 feet of the string out, the kite is 100 feet above the ground. What is the angle of depression from the kite to her hands? Okay, well, I'm going to draw Kate down here. And then I've got a kite that she's holding up here. And I know that she's letting all 300 feet of that string out. Now it says that we're trying to find the angle of depression to her hands. Remember, angle of depression starts at a horizontal, so I'm going to need a horizontal line here. So my triangle is going to look like this. The angle of depression, so from the horizontal down, is going to be what we're looking for. That's x. Okay? So we're trying to solve for. Now, I know that she is 2.5 feet from the ground to her hands. But I also know that the total distance from the ground to up here is 100 feet. So that means the distance from here, her hand, to the top is 100 minus the 2.5. Okay? So that means that this distance would be 97.5. I have to account for the fact that she's holding it 2.5 feet above the ground. Okay, so now we go through our steps. Step 1, identify our angle. It's x right here. Step 2, label all of our side choices, side lengths. This is our hypotenuse. This is our adjacent because it's touching our angle. And this is our opposite. Step 3, identify which trig function we're using. We're using the hypotenuse and the opposite. So we are going to use the sine for this function. Step 4, set up an equation. We're using sine, so we'll start with the sine. And then our angle, which is x, and that's equal to our ratio, opposite over adjacent, or opposite over hypotenuse, excuse me. So 97.5 over 300. Okay, now we need to decide, are we using, or are we looking for a side length or an angle? We're trying to solve for this angle right here, x, so we're going to use an inverse trig function. Okay, so that's going to look like, if I'm trying to get x all by itself in this equation, remember the only thing I have to do is leave our x and use the inverse trig function on the other side. So if I put the inverse sine of 97.5 over 300 in my calculator, and I round that to one decimal place, it actually rounds up to an even 19 degrees. Okay. Example J, from the airplane you measure 29 degrees angle of depression to the airport runway, which is 8,495 feet away horizontally. What is the plane's height above the ground? Okay, so I've got a plane. I'm going to draw my plane real quick. Okay, here's my plane, and down here I've got a runway. Now I'm measuring an angle of depression from the plane. Angle of depression starts with the horizontal, so it's going to start like this. It's going to go down to the runway. And then it's going to come back up towards the plane up here. Okay, so there's my triangle. So my angle of depression starting at this horizontal going down because it's a depression, is 29 degrees. And it says that the airport runway is 8,495 feet away horizontally. So from the airplane to the runway is 8,495 feet horizontally. So this top, and I'm trying to find the height of the plane to the ground. So that's my X. Okay, let's run through our steps. Step 1, identify our angle, 29 degrees. Step 2, label our side choices here. Hypotenuse is my diagonal line. My adjacent is touching this angle, and my opposite is what's left. Okay. Step 3, identify which trig function we're going to use. Well, we're using the adjacent and the opposite, so that would be a tangent function. And now, step 4, set up a trig equation. So we start with tangent, because that's the trig function we chose. The tangent of our angle, 29 degrees, is equal to our trig ratio, which is opposite over adjacent. So it's x over 8,495. Okay, are we solving for a side length or an angle? We're solving for a side length in this case, so we're going to use a normal trig function. So I'm going to cross multiply here, and when I do cross multiply, I'm going to end up with 8,495 times the tangent of 29 is equal to x. Now I can type in 8,495 times the tangent of 29, and I end up with x is equal to 4,708.9. That is how high the plane is from the ground, 4,708 feet above the ground. Okay, now K is going to be partner practice. So we're going to practice this with our table mates, and then come get that checked off when you have it finished.